Hello, welcome to Rhombus. On the coordinate plane shown, the circle has an equation of x minus 8 whole squared plus y minus 6 whole squared is equal to 25. There are some lines that can be drawn through point 7, -1 that intersect the circle in 2 points. As an inequality in the form of a is less than m, which is less than b, where a represents the smallest slope and b represents the largest slope, what's the range of possible slopes of all lines which intersect the circle in 2 points? The first way we'd solve this problem is we should find out the slope of the lines which only touch the circle at one point, because if we find out the slope of those lines, we know that anything between the slopes of those two lines would intersect the circle twice. So let's first draw the two lines. So here's one line that touches the circle only at one point. So it only touches the circle at this point right here. And another line which does the same thing as well is this line right here. It only touches the circle at this point. So if we found out the slopes of those lines, we'd know that any slope in between these 2 points would touch the circle twice. For example, this point would touch the circle, this line would touch the circle twice, since it touches this point above and this point below. So if we were to find out the slopes of the two orange lines that I drew, we'd be able to find out the value of AB and get our inequality. So in order to do that, we must construct the following triangle. So this is a right triangle since it touches one of the orange lines we drew. Let's give all the points names so we can refer to them throughout the video. So that will be A, this will be B, this will be C, this will be D, this will be E. And point 7, -1 will be F. So we can make a triangle with points E, F, and then the intersection point of the circle and the orange line. We'll just name this O1, and then this will be O2. So we need to first find out what type of right triangle this is. If we know that the radius of the circle is 5, since if we look back at a circle equation, so our circle equation is x minus 8 squared plus y minus 6 squared is equal to 25. We know that the square root of 25 is our radius of the circle. So the square root of 25 is just 5. So we know that this length is 5. Now let's find out the length of EF. So EF. We can do that by using the distance formula since we have two coordinates right here. So the distance formula is D is equal to the square root of x2 minus x1 squared plus y2 minus y1 squared. So if we plug in our values, we can get the equation. So x2 will be 8 and x1 will be 7. So 8 minus 7 squared plus y2, which is 6 in this case, minus plus 1, because it's a -1, and square that. So 6 plus 1 squared. Let's simplify this. We'd get 1 plus 49, because 7 squared, which gives us the square root of 50. And if we simplify that into a radical, we would get 2 square root, oh, not 2 square root, 5 square root 2. So that's the value of segment EF. Now, if we look at this triangle, we have two lengths already. We know that one of the legs is 5, and we know that the hypotenuse, or the longest leg, is 5 square root 2. This is a 90, 45, 45 triangle. So if we know that those two legs are 5 and 5 square root 2, we know that the other leg is also 5. So we just found out the side lengths of our first triangle. Now let's draw a second right triangle. So we're going to touch the origin, so 0, 0. We're going to touch the intersection point of line O1 and point F. It is tangent to the blue triangle we drew earlier. We already know that the side length is 5, one of the legs is 5, and now let's also find out the hypotenuse of this triangle. Let's use our distance formula again. So let me erase this work so we have some space. So the distance formula we can use again to solve this problem. So the square root of, in this case, x2 will be 7, and then x1 will be 0, squared plus -1 minus 0 squared, which gives us 49 plus 1, because -1 minus 0 is just -1, and then if we square a negative, we just get the positive value of the square. And if we do that, we get the square root of 50 again, which is also equal to 5 square root 2. So for this hypotenuse, it's also the 5 square root 2. And we know that the leg is 5, therefore this is a congruent triangle to the blue one we made earlier, making the second leg 5. So using this information, we found out that this line, so let me draw that line out. After finding out the triangles, we found out that to the origin and point 8, 6, that is parallel to line O2. Since these 2 points are perpendicular and these 2 points are perpendicular, we can say that it's parallel to O2. Now, because we know it's parallel to O2, that also means that the slope of this purple line is equal to the slope of O2. So let's find out the slope of the purple line. We'll name it, let's give this point name G. So let's find the length of GE. To do that, we have to take in our formula, which is y2 plus y1 over x2 plus x1. Let's plug in our values, which gives us 6 plus 0 over 8 plus 0, and that turns into 6 over 8, which gives us 3/4. So that's the slope of the line O2. So let me write that down, 3/4. Now, because the two lines are perpendicular right here, we can just take the reciprocal of 3/4 to find out the slope of O1. So the reciprocal of of 3/4 is just -4/3. Now that's the slope of O1. So now that we have the two slopes, all we have to do is write our inequality. Our inequality will be in this form. So let me erase some of the stuff. Our inequality has to start with A, where A is the smallest slope. So that'll be -4/3. Oops. One sec. -4/3, which is less than m, which is less than our largest slope, 3/4. That is the answer to this problem. Thank you for watching. Don't forget to subscribe and share these videos to friends who might need help with math like this. I'll see you next time on my channel, Rhombus.